Hi, good day. I'm Kingie Divinagracia, and today I will be discussing about algebraic specification. So, algebraic specification is another popular descriptive specification style, which is based on the use of algebra rather than in logic. So, algebraic specification is a formal specification approach in order to provide an abstract and implementation-independent definition of data types. So today, algebraic specification is a well-known formal method for software development. So algebraic specification is a software engineering technique for formal specifying system behavior. So what is formal specifying? So formal specifications are mathematical-based techniques whose purpose are to help with implementation of system and software. They are used to describe a system, to analyze its behavior, and to aid in its design by defining key properties of interest through rigorous effective reasoning tools. So these specifications are formal in the sense that they have syntax and semantics. And algebraic specification seeks to systematically develop more efficient programs by first is formally defining types of data and mathematical operations on those data types. Second one is the abstract implementation details such as the size of presentation or in memory and the efficiency of obtaining outcome of computations. Third is formalizing the computations and operations on data types, allowing for automation by formally restricting operation to this limited set of behaviors and data types. But traditionally, algebras are homogeneous, which consists of a single set and several operations, like the integers, together with operations, addition, subtractions, multiplication, and so on. And that is called homogeneous algebra. By contrast, in heterogeneous algebra, for example in alphabetic strings, which is the sequence of characters, together with the operation of concatenation, which is the appending of a string to another string, just like combining the two strings. And the length, since the range of the length operations is the set of integers, not the set of strings. So we say that this algebra consists of two sets, which is the string and the integers, in which the operations length and concatenation are defined. Heterogeneous algebra, from the definition itself, the collection of sets together with operations is quite close to the notion of an abstract data type. So ADT, or the abstract data type, defines only the variables and methods, including the parameters and return types of those methods, without determining how they are implemented. Again, without determining how they are implemented. That's why it's abstract. You're determining what the data type can do, but not how it does it. So for example, in ADT, we use abstraction when we need to separate the how from the what. The what is the start button on the card game. The how is the shuffle of the deck. The how is the abstract. So what does it mean? So each time you launch a card game on your smartphone, a game loads. Well, you don't need to know all of the processes that occur behind the scenes. If you click start, you don't need to know how the cards are shuffled or counted. All you need to do is to click the start and play. We don't have to know anything about how the game is launched or what internal programs are run on the phone to make it happen. All you have to do is to push a button. For example, in algebraic specification, which is specify the system to manage strings. Suppose that we want to specify a system to manage strings. The first relevant tags that one should record are first the operations needed, and the second one is the sets involved in such operations. In this case, assume we want to manage strings by first creating new, which is the empty strings, considered as the empty strings. Here is the operation, which is the new. Second one is the concatenating strings, and its operation is append. And third one is the adding a new character at the end of a string, and its corresponding operation is add. Next one is the checking of the length of the given string and its operation, which is function length. The next one is the checking whether string is empty. So there will be a function or an operation is empty. Second one, the next one is the checking whether two strings are equal. So the operations or the functions which is the word itself, equal. Short inspection of this list shows that the sets involved, besides the set of strings itself, which is the string, or first is the char, which is the set of alphabetic characters. Next one is the math, which is the set of natural numbers. The boolean, the set of logical values. So this set is by a system to manage strings. So the collection of sets that form the heterogeneous algebra is called its signature. So each set in such given signature is called a sort of the algebra. To define a heterogeneous algebra, we first need to specify its signature that involve operations under domains ranges. This definition called the algebra syntax. The requirements for annotation, there will be a principle for that, which is the separation of concerns. So separation of concerns is a design principle for separating a computer program into distinct sections, such that each section addresses a separate. So the word concern is a set of information that affects the code of a computer program. A concern can be as general as the details of the hardware the code is being optimized. So the value of separation of concern is to simplify or simplifying development and the maintenance of computer programs. In natural identification for specification, whenever possible, for example, a functional specification should be kept separate from performance specification and from the user interface specification and so on. So sometimes separation of concerns may even result in using different notations for specifying different aspects of a system. So, for example, suppose that you wanted to describe the production of a document in an office automation system. The DFD, or the data flow view or data flow diagram, which is in the figure, describes which sources of information and what kind of data are necessary to produce the document. So, for example, a library of predefined templates say that contracts of several types in which specific data such as names, dates, and amounts are missing. Second one is the database of customers who already have been in touch with the office, the customers themselves. And last one is the set of predefined formats to be selected to print the document. So in the figure, however, does not specify the order of execution of the actions that lead to the composition and printing of the document. So this is specified by the control flow view, which is in the figure, which shows that after having gotten the customer's name, we may get further data, the customer's address, the date of birth, etc., either from the customer database or through more interactions with the customer. This is intuitive evidence that if the customer's record is already in the database, then the edge get other data from the database is followed. The alternative edge is followed if the customer's record is not in the database. So, however, it's not stated explicitly in the figure. If we wanted to be more precise, we could augment the model by adding suitable labels to the edge to specify the conditions under which it will be followed. As an alternative to an FSM to show the control requirements, we can use UML sequence or collaboration diagrams.